In Section 6, we're going to talk about SQL and NoSQL database systems, some XML and JSON and how they relate to SQL and NoSQL. Then we're going to do data selection, data conversion, subsetting the data to slice it and get smaller pieces. And then we're going to cover the date-time APIs and how they factor in, as well as a little bit of resampling to go through and get a different perspective on the data that you have. In this video, we're going to talk about SQL versus NoSQL database systems and do a little bit of compare and contrast. Now, the first thing we're going to cover is NoSQL. Then we're going to go into the role of what is the difference between SQL and NoSQL systems, what do they have in common, how are they different, and then we're going to talk about a couple of various NoSQL systems that you can choose from. Now, one thing that a lot of people can agree on regarding NoSQL is that it's really just a terrible name, and it's actually very misleading in terms of what it actually is. Because NoSQL really just means that it's a non-relational database, so it's not oriented in terms of the typical row and column layout that your typical relational database is. Instead, NoSQL systems can get their improved performance based on being document-based or graph-based, or focused on key values. And it's these areas that potentially allow a lot of the NoSQL systems to excel because they're able to dedicate a lot of performance optimizations towards certain data types. And back in 2013, there was a pretty funny graphic that went around that was called History of No-tation, given that it was for NoSQL. So back in the 1960s and 1970s, when SQL needed to be invented, there was a term that says, well, we have NoSQL. And then, of course, people said NoSQL because now it's popular and you have to know it, so K-N-O-W. And then in 2000s, databases became very critical to a lot of the internet infrastructure. So it was, are we using a different type of storage? No, we're using SQL. And then the NoSQL trend came along, and of course people said, well, we're using NoSQL now. And after a while, people had a chance to go through what Gartner refers to as the hype cycle. They realized that NoSQL doesn't necessarily have to replace all the SQL databases, so we've come back to no-SQL, in that SQL databases still have their place within the industry. And around the time that this picture started going around, there was a chart that gave us the comparison between NoSQL and SQL systems. And the big ones to pay attention to on this chart, ones of, is it a standard? So NoSQL is really a thing that any particular database vendor can do to call their system NoSQL, but they all behave a little bit differently. So unlike what you'd expect with SQL using SQL 92 or SQL 2013, there is no actual defined standard for the way that you query NoSQL databases, which is good because those databases can optimize for their own, but it's bad in that you have to redo your usage of the API as you change within the systems. Now, certainly some of the other items in this chart are opinion-based of can it handle unstructured data models, which is in a sense what a lot of the NoSQL systems are good for, and then the one right below it of can it handle graph data, because some of the particular NoSQL systems that I tend to use are entirely graph-based. So they're actually pretty good at handling graph data. And then in terms of can it scale up and can it scale out? Well, a lot of those NoSQL systems do tend to be good at this, but with a catch on the standard ACID-based transactions. In the chart, NoSQL gets a 5 and SQL gets a 12. So why would you choose NoSQL at all? And the main reason that everyone does is that NoSQL is extremely good at its dedicated purpose. So columnar storage, like your Apache Cassandra, document-based, like your MongoDB, they're all able to perform extremely well at these particular uses. MongoDB is probably the best known amongst the NoSQL databases and is extremely popular to anyone you talk to regarding NoSQL. And the reason is that it's an extremely well-performing database that will give a high amount of throughput and query volume to any application that you're choosing to write. Another popular NoSQL database is Apache Cassandra, which is a key value-based store to insert a variety of information that you need and is able to scale to extremely large sizes in a cluster. And one of the reasons that I tend to use this database is it works with a graph overlay called Apache Tinkerpop to query it using the gremlin syntax. One other graph database that I tend to use is called OrientDB, that on their website publishes a comparison between themselves and MongoDB, which is an immediate way to see where they place themselves. OrientDB makes for a great centralized graph and also has a very nice querying interface as you write your gremlin queries against the database to examine what happens against the schema. And one of the smaller graph databases is largely a graph overlay over a variety of other storage options called JanusGraph that is an open source system that also works with Apache Tinkerpop in order to get you your graph overlays in terms of systems like Apache Cassandra, DB, or a variety of other databases. And then looking at the market trends for all of these NoSQL systems, we can take a peek at some of the Indeed data in order to look at the job trends for this graph for what are you going to be able to do with the skills that you learn about in NoSQL. And what we can see from this is that SQL definitely has more of a market share. Certainly it's been changing, but it's also been around since the 1960s or 1970s, so we would expect it to be bigger. And the real question in terms of which you choose is, what are you personally interested in, and what problem are you trying to solve and use this data for?